Hello and welcome to this demonstration video of how the analog to digital conversion works on the Arduino. As our product's accuracies are dependent on both the supply voltage and ADC reference voltages, we want you to be aware of some of the pitfalls. Hopefully you will also have use for this in your other projects. And remember, YouTube is full of tutorials and guides with a much more in-depth explanation than this video. The functionality in this video is the same regardless if you used Arduino Uno, both the original and SMD versions, as well as the Arduino Mega. We will, however, only be demonstrating the ADC using the original Arduino Uno. Assuming that you already understand the basic concept of an ADC, we will instead direct your focus to the ADC reference. For the Arduino, as clearly stated, the default ADC reference is the 5V supply voltage. In an ideal case, measuring 3.3 volts with a spot-on 5.0 volt reference voltage, the 10-bit ADC of the Arduino Uno would convert it to the integer value of 675. Let's do a practical test of this by connecting the 3.3 volt to one of the analog input pins, in this case pin number 5. Using whatever means you have to measure voltages, let's see what we have on the 5V pin, our reference, as well as the 3.3V pin, our measured voltage. Although connected to a desktop computer, my USB 5V is actually only 4.5 volts. The 3.3V we are measuring is however accurate. As you can clearly see in both theory and practice, measuring 3.3V gives very different results depending on the accuracy of the reference. And here is the first mistake when using Arduino to measure voltages. By default, it uses the 5V from the USB as the reference, which is highly inaccurate, as we have just proven. Now, how can we get a more accurate 5V, in this case also our reference voltage? One way is to power the Arduino by an external power supply. By enabling the built-in voltage regulator, let's see if we can improve the accuracy by again measuring the 3.3 volts. The 5V is now close to ideal, and we only have an error of a few bits. Compared to previously, when the error was around 80 bits, it's a big improvement in accuracy. Now, let us do the same measurement, this time with the Lambda Shield stacked on top of the Arduino. No change in results. Good news! The Lambda Shield is already designed to take advantage of this. By putting a jumper on the connector X7, we can actually use the same 12-volt power supply to both power the oxygen sensor as well as the Arduino, as you can see in the results. Now, thank you for watching. Good luck in your next project, and remember to read more about powering the Arduino as well as accuracy in the technical manual found on our website.